Good morning. We are off and running with lesson 5.6 and it's good stuff today, y'all. Using the distributive property. Now you first learned about the distributive property in the 3rd grade. Okay, so this is kind of just jogging your memory a little bit and then of course adding on since you're in 6th grade now. But this concept isn't completely new. The distributive property, first of all, we're going to be in your workbook on page 305. So go ahead and turn there. Sorry about that. Page 305. And I'm going to be looking at the bottom of the page real quick before we turn. The distributive property, if you're right here with me, states that to multiply a sum by a number, multiply each term inside the parentheses by the number outside the parentheses. Okay, so let's look at what that means. If you look down here with this numerical expression, I see a sum right here, a 5 plus 6 in parentheses, and a number outside of it. The distributive property says you can take this number on the outside and multiply it by each term. So like 2 times 5 and then 2 times 6. That's basically the distributive property. Okay, so don't overcomplicate it. Okay, so notice it says 2 times 5 right here plus 2 times 6 right here. That's what the distributive property tells us. Okay, if you have variables, you do the same thing. You would have A times B, which is AB. We can write it that way. And then A times C, AC. Okay, let's turn the page. All right, so it gives us a few more examples here. It talks about expanding this expression. Again, it's what we just did. This would be A times B and A times C. Okay, and notice you can write it like this. If we have numbers, again, let's look at this one. If you have 2 times 3 plus 5, I do want you to notice if you followed normal order of operations, you would do parentheses first. 3 plus 5 is 8. So you would have 2 times 8, which is 16. Okay, well notice using the distributive property, you get the same answer. Okay, now when you have numbers, you can do it either way, but the distributive property comes into play later with other things, okay? But if it's just numbers, you could solve it either way. But notice if you use the distributive property, you could say 2 times 3, okay, right here, and 2 times 5. Okay, 2 times 3 is 6. 2 times 5 is 10. Put it together, 16, just like we got when you used order of operations. Let's look at this example. Now, you had one of these like on one of your Aspire packets, and a lot of you didn't know what to do because you hadn't learned it. Okay, but look at how easy it is. You would just say 3 times x. Notice they do those arrows here. 3 times x and 3 times 4. Okay, well 3 times x is just 3x. You don't have to put the dot, okay, in algebra. And 3 times 4 is 12. And that's it. You would just leave it like that in algebra. You can't do anything else because you don't know what x is. So that would be the answer. Okay, so let's look at the next page at some of these examples. Okay, use the distributive property to expand 2 times x plus 3. Okay, so again, all you would do was say 2 times x and 2 times 3. Okay, 2 times x is 2x, 2 times 3 is 6. So if you expanded this, you could say it's 2x plus 6. All there is to it. Okay, why don't you try this one really quick? It takes like 2 seconds. And then check and see what you get. Okay, I've given you enough time. You can probably have done it. This would give you 8x. Notice I use a plus sign because there's a plus sign here. 8 times 3 is 24. And that's it. Just leave it like that. Okay, now I think this is interesting. This is a really good use of the distributive property when you have fractions and you're multiplying a mixed number and a whole number. Look at what you can do. Okay, now you've been taught, if you were going to multiply these, you could make this improper and multiply that way. But look at using the distributive property. You can look at 3.5 as like two pieces. You have your whole number and your fraction. It's like saying, okay, when I multiply 3.5 times 8, I'm multiplying the 8 times the 3 times the whole number, and then the 8 times the half, and putting those together. Okay, so notice down here, they separate the 3 from the half and say it's 3 plus a half, which is 3.5. So you can see this a little better. So then you say 8 times 3, they put that here, and 8 times a half. So you can put this here. Okay, 8 times 3 is 24. 8 times a half, or a half of 8, is 4. Put them together, the answer is 28. Okay, a really nice use of the distributive property. Okay, so I want you to try that. Okay, look at the check at the bottom. Pause the video and then see what you can come up with. Okay, if you use the distributive property, you're essentially doing 12 times 2 and 12 times a fourth. Okay, and you can do that mentally. 12 times 2 is 24 plus 12 times a fourth, or a fourth of 12, or 12 divided by 4 is 3. So put those together, your answer would be 27. Okay, let's turn the page. Feel like we're doing pretty good here. Okay, now, this next part, you will actually end up using a lot when you get to algebra. This says the greatest common factor and the distributive property. Okay, let's look at some of this. You can use the greatest common factor to rewrite the sum of two whole numbers with a common factor as a product. Okay, I know that's a lot. This is pretty wordy here at the beginning. It says when the numerical or algebraic expressions are written as a product of their factors, the process is called factoring the expression. Okay, so you are going to do a lot of factoring in your future, in your math career. Factoring is kind of like using the distributive property backwards. Okay, and these are the steps you go through, and you're going to see what I mean once we just do some problems. These are your steps. You're going to find the GCF of the terms you're looking at. You're going to write the terms as a product of factors, and then you're going to rewrite the expression as the product of two terms. Okay, so this is what all that means. This says we're going to factor the expression 8 plus 56. Okay, and I'm sure you're asking, like, why would I do that? They're using numbers so you can kind of see how this works. You use this in algebra a ton. Okay, so what you're going to do, basically what I usually say is when you are factoring, you're pulling out what's in common with both of those terms. Okay, you're pulling out what's in common with both of those terms. Okay, so when I say what's in common, I'm saying, what's the GCF of these two terms? What is their greatest common factor? Now, we worked on that yesterday. Or what number divides into both of these? Well, 8 does. Okay, both of these can be divided by 8. Now, if you've forgotten how to do that, or you need a little refresher, okay, you can do the factor trees. Notice they've just listed the factors here for you, but it would have come from if you did your factor trees and said, okay, 8 is 2 times 4, and 4 is 2 times 2. Okay, so 8 is equal to 2 times 2 times 2. 56, well, let's see, 56 is 7 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So remember when we found the GCF, we circled what was in common with both of them. They both have a 2, and they both have another 2, and they both have another 2. So notice that that is what the book is doing right here, okay? They've listed 8 as 2 times 2 times 2, and 56, 3 2s and a 7, and they circled the 2s. So the GCF is 2 times 2 times 2, or 8, okay? Your GCF is 8. But you could have looked at both of these numbers, and if you'd said, oh, I could divide them both by 8, that's mental. Okay, now, so what you do is you say, okay, I'm going to rewrite this 8 as 8 times what? Well, 8 times 1, okay? And 56 is 8 times 7. Now, if I pull out what's in common with both of these, it's an 8. So it's like I pull out this 8 from both of them and put it here, and I write in parentheses what is left over. What is left over is a 1 in the first term and a 7 in the second term. So 1 plus 7, okay? And this is now factored, okay? So again, thinking about pulling out the term or the factor that is in common with both of these numbers, okay? They both have an 8 in common. I pull that 8 out front and I look at what is left over from both terms, okay? So let's look at this with an algebraic expression. If you have 45x plus 6, okay? Now again, you can look at these two numbers and think to yourself, okay, what could I divide both of these numbers by? What is their GCF? Now some of you can do that easier than others, okay? So if you need to draw your factor trees, that's okay, okay? So if I did that, I could say, okay, 6 and 45. 6 is 2 times 3. 45 is, let's see, 5 times 9 and 3 times 3. Okay, so what do they both have in common? Well, the only thing they have in common is a 3. Okay, so the GCF is 3. So if I am going to pull out what's in common, what I'm going to do first is write 45x is 3 times what? Okay, 3 times 15x. 6 is equal to 3 times 2. Okay, so notice once I figure out that GCF, I'm going to rewrite each term as 3 times what? Okay, 3 times 2, 3 times 15. Okay, now once I see that 3 is in common with both of them, I pull it out front, right here, and I write what was left over. What was left over was a 15x and a 2. Okay, and notice to check yourself, you can always use the distributive property and see if you get what you started with. Okay, 3 times 15x is 45x. 3 times 2 is 6. Okay, so I did it right. Okay, I know this is kind of a new concept for you, factoring, so it might take a little bit for this to stick. Okay, so let's look at this next example. It says, use the GCF to factor numerical expressions. Okay, so now you're going to try what I just showed you. Okay, so if you're looking at factoring 45 and 72, okay, first of all, I think, what is the GCF of both of those numbers? What could I divide them both by? Well, a 9 goes into both of them. Okay, that's the GCF. Okay, so if 9 is my GCF, I'm going to write 45 as 9 times what? 9 times 5. And 72 is 9 times 8. Okay, now I'm going to pull out that GCF, what's in common. I put it out front, 9. And then I just write what was left over from each term. This one had a 5 left. This one had an 8 left. So it's factored. Notice that's what they got. Okay, and you can put that in the blank if you want to. 9 times 5 plus 8. Okay, So now you try one, okay? So go ahead and pause, give it a shot. If you need to do factor trees to find the GCF, do that first. Okay, so pause and try it and then come back. Okay, now again, if you have trouble with that GCF, just do the factor trees really quick. You'll get good at them if you do them a bunch. Okay, 80, 8 times 10, 2 times 4, 2 times 5, 2 times 2. Okay, so I broke down 80. Now I'm gonna look at 56, 7 times 8, 2 times 4, 2 times 2. Okay, so let's see what's in common with both of them. 2 and a 2, 2 and a 2, 2 and a 2. This one, all it has left is a 7. There's not a 7 over here. So their GCF is 2 times 2 times 2. Okay, which is 8. GCF is 8. And you might have been able to tell that by looking at those numbers. Okay, so now let's write both of these as a product of the GCF. So 80 is 8 times 10. 56 is 8 times 7. Okay, so now I'm going to pull that GCF, that 8 out front, and I would get 10 is left in this term, 7 is left in this term. Okay, again, if you distribute it back out, 8 times 10, 8 times 7. Okay, that's what I started with. All right, let's go to the next page. Okay, now we are going to use the GCF to factor an algebraic expression. Okay, so if I look at this first one, okay, let's think about what's the GCF of 6 and 15. What divides into both of them? A 3. 3 goes into both those numbers. So 3 is the GCF that I will pull out front. Okay, but first let's write these both as a product of 3 and something. So 6x is 3 times 2x, okay? So notice 6x would be 3 times 2x. 15 is 3 times 5, okay? I pull the 3 out front and write it here, and then I write what's left in both terms, a 2x and a 5, okay? So if you factor this, you get 3 times 2x plus 5. All right. Now you try one with algebra. This is real algebra, so you give it a shot. Okay, now if you've come back and you've tried this, now let's see what you got. The GCF of these two numbers is 6. Okay, so I would say 36x would be 6 times what? Well, 6 times 6 is 36, and I just kind of leave the x there. 30 is 6 times 5. Okay, so then I say, okay, I'm going to pull that common factor out front. It's a 6, and write what's left, 6x plus 5. Okay, and notice if you use the distributive property back, 6 times 6x would be 36x. Here, 6 times 5 is 30. All right. Okay, so now we're just to the apply problems on the next page. So let's look there. Applying money. All right. Wynn is buying bottles of apple juice and wants to mentally calculate how much they will cost. He buys 5 bottles of juice at $2.15 each. Use mental math and the distributive property to determine how much change he will receive from $20. Okay, so this one I had to kind of think about for a second, like how they wanted us to use the distributive property. But think back on the example when we used it with the fraction. They split up the mixed number into a whole number and a fraction. Okay, let's apply that same concept to dollars and change. Okay, if you're thinking about 5 bottles of juice at $2.15 each, okay, to get the total cost, you're multiplying those, right? Okay, and you can do that, but let's use the distributive property to do it mentally, okay, and quickly. That would mean you're multiplying the 5 times the $2. Well, that's easy, $10. Plus 5 times 15 cents. Okay, well, 5 times 15 is 75, so that's 75 cents. I'll write it like that. So the total cost is $10.75 for the juice. And look how easy that was. We did it mentally. Okay, now, if you want to know the change from $20, you know you just subtract. Okay, and you could set it up where you have to borrow across the zeros and do it that way. Okay, but let's use maybe another strategy. Watch this. If you said, okay, if I'm going to take $20 and subtract $10.75. Okay, well, let's think about saying, okay, well, $20 take away $10 is $10, right? But then I still have to subtract the 75 cents. Well, what's $10 take away 75 cents? Well, it's $9.25. And that would be the answer. Okay, so that's a little bit of mental math where you don't have to write down and subtract across the zeros. But if you want to do it that way, do it and check me. You get the same thing. Okay, final problem is on the next page, last page. Okay, it says Martin exercised 4 days for 65 minutes each day. His goal is to exercise for a total of 300 minutes in 5 days. So he's got one more day to exercise. How many minutes does he need to exercise on the 5th day to meet his goal? Okay, now you could have done this before this lesson. It's nothing new, but it's maybe trying to stretch your brain to solve it a different way today. And I actually thought about this problem 2 different ways, so I can show you both and you can do it whichever way you want. The first way might be to just say, okay, if he's exercised 4 days times 65 minutes, you could just think about it, instead of multiplying that traditionally, you could do it this way. You could say, well, 4 times 65 is really 4 times 60 and 4 times 5. You could do it that way, right? I mean, you don't have to write this, but you could think about it that way. Well, 4 times 60 is 240, and 4 times 5 is 20. So if you put those together, you would get 260 minutes. Okay, well, if his goal is 300 minutes, what's 300 minus 260? Well, it's 40 minutes. Okay, so 40 minutes. Okay, and that's probably the easier way to do it, even though I thought the first way I thought is harder, but I'm going to still show you. But that's one way to kind of apply the distributive property to do some mental math there. Okay, the other way was using factoring. So both ways we learned in this lesson, but I thought about it this way maybe. His goal is 300 minutes. Okay, he has already practiced or exercised 4 days at 65 minutes. Okay, well, I thought about maybe trying that factoring process. This is kind of already separated into 4 times 65. So I thought about saying, well, can I do 300 is 4 times something? Does 300 divide by 4 evenly? And it does. Okay, 300 divided by 4 is 75. So notice I could say, okay, well, 300 is 4 times 75. Now that's maybe more mental math than you could do. But notice this. I have 2 terms here and they both have a 4 in common. If I factored that 4 out front and then wrote what was left in each term, 75 is left here, 65 is left here. Now check out this mental math. 75 minus 65 is 10. So I'm left with 4 times 10 or 40 minutes. I get the same thing. Okay, so I thought that was kind of cool. This might be a little bit harder for you to wrap your mind around because it's the factoring, but this I feel like you can handle. Okay, either way works. All right, I've talked long enough. You give it a try, and like I said, it's new, so it might take you a few days, but you will use it a ton. All right, y'all have a good day. See you later.